Welcome to Lesson 44 on Anonymous Methods Part 7, which covers the filter higher order function. Lesson 44 is the accompaniment to How to Program Effectively in Delphi for AS A-Level Computer Science, Chapter 44. The filter function is a higher order function that processes a data structure, for example a list, in some order to produce a new data structure containing exactly those elements of the original data structure that match a given condition. For example, filter can apply the even function to every element of the integer list 1 to 10 and return a list containing integers that possess the property of evenness. So in shorthand notation, filter can apply the even function to the list 1 to 10, where the filter function consists of two arguments, an anonymous function that represents the even test, and an array of integer that represents the integer list 1 to 10. The anonymous function tests for evenness by dividing by 2 and testing the remainder to see if it's either 0 or 1. If it's 0, then the item is exactly divisible by 2. The item will be one of these integers from the list 1 to 10. Okay, let's have a look at the Delphi program that implements this filter. It's called Introduction to Filter Project. It's a console application. It has a function type, t function of integer, which references a function of a single argument, which returns the result true or false. We have a dynamic array type, t array of integer. We create a reference, an array of integer to a dynamic array, and it's initialized here in two stages. The first stage is to grab enough memory to store 10 integers, and the second stage is to store these specific integers in the allocated memory. We have a dynamic array reference, another array of integer, which hasn't been initialized yet. We have a filter function which is going to iterate through the array that's passed to it. Since there are 10 elements, the variable I will go from 0 to 9, because an array of integer, or the array of integers, the formal parameter here, is a dynamic array, and indexing starts from 0 with dynamic arrays. So then we do a Boolean test by applying the anonymous function. F is a reference to a function type to the next element of the array of integer. So first time through, array of integer will have index 0, next time through index 1, and so on. In this way, we're going to step through the values of this initialized array. So the anonymous function, which is referenced by F, is this one here, and all we're doing is testing for evenness by testing to see if the item is exactly divisible by 2. Now, this anonymous function will return true or false, and if it's true, we increment count. So the first time, count will go from -1 to 0. The variable new length is initialized to 0. So if we increment new length, that will go from 0 to 1. So now we're going to set the length of result to a new length of 1, so it will be a 1-element array. Now remember that Delphi automatically creates result on entry to filter, and result will be the same type as the return type of the function filter, so it will be a dynamic array. So we can use the set length standard procedure to create a dynamic array of length 1, and then the next time through we will be extending the array by a new element, so it will be a length 2, and so on and so on. Result will store the element which has passed the evenness test, so it adds that item to this result array. Count is the index, and we said that the first time through on discovering an integer which is even, count will be incremented from -1 to 0. So this will reference the first cell of this dynamic array result. And as we loop through this for loop, if we find another even number, then the count is incremented again, new length is incremented, and we set a new length so that we can extend the array, and we store the new integer, even integer, in the newly added element to the result array. So set length is extending the result array, which is a dynamic array, and result count is storing the integer which passes the test of evenness. Okay, and finally, when the for loop is exhausted and filter returns, it returns the array result, well, result which is a reference to a block of memory, so it will return the address of this block of memory which contains the even numbers 2, 4, 6, 8, 10, and assigns this address to this dynamic array reference variable, another array of integer, and then we just iterate through that to display the even numbers that have been found in the array, an array of integer. Okay, let's run the program. This is the program. So if we run it, we do get indeed get 2, 4, 6, 8, and 10. If I extend this list, and run it again, so then we get 2, 4, 6, 8, 10, 12, 14, 16. If I change the even anonymous function to an odd function, I do that by changing the test from 0 to 1. Run it again. Then we find all the odd numbers. Let's now look at a more interesting application of the filter higher order function. In this case, we're going to look at an example that provides a word list for the game of Scrabble. So the program is called Words Project. It's a console mode application. We have a function type T function of string, which is a reference to an anonymous function of a single string argument and return type Boolean. We're going to supply the filter function with a word list, and we're going to apply the filter function to this word list and return a new word list. We create an inline inferred data type variable filtered new word list, and it's going to be a reference to a t-string list, which we create by using the create method of the class t-string list. And then we iterate with another inline inferred type variable word over the given word list, which is the first argument of the filter function. And we're going to test the word to see if it meets the criterion or not. If it does, then this will return true, and then we can add the word that we just tested to a new list called the filtered new word list, which we just created here. The result variable will automatically be created by Delphi, and it will be the same data type as the type here. So when we've finished iterating through all the words in the given list, we'll end up with a new list containing all the words that meet the criterion, and then we can return this via result to the calling program. Okay, so in the main begin end block, we have another inline inferred data type reference variable word list, which is going to reference a list which we've created with the create procedure class procedure belonging to the class t-string list. Then we use the method load from file to initialize this word list, and we're going to use a text file which already contains words in alphabetical order of different lengths. We're going to ask the user to input the word length to filter on, and we read it at this point into the word length variable. It's an integer variable. We create another inline inferred data type reference variable new word list, which is going to be of type t-string list. And when we've finished filtering, the filter will return the new word list. The address of this new word list will be assigned to new word list. And if the count isn't 0, we can then write out every word in this new word list. And we can also, when we finished writing the list of words, write the number of words in the list. So let's have a look at this anonymous function. It takes a word and it tests the length of this word against the word length supplied by the user, and it returns true if it matches or false if it doesn't. And we're filtering the word list which we've loaded from this file sopods.txt. So using an anonymous function makes it very easy to change the filter criterion. Let's have a look at the Delphi program that implements this Scrabble example of the use of the filter higher order function. And it's as described in the previous slide. Sopods.txt looks like this. and it contains 267,544 words, and this file, soapods.txt, can be downloaded from this site. Okay, let's run this program. And let's find all the words of length 5 in soapods.txt. And there are 12,464 words. Let's find all the 4-letter words. And there are 5,447. Let's find all the 6-letter words. And there are 22,133. Let's find all the 7-letter words. And there are 32,879. Zuffali, Zuffalo, Zydkos, Zygomas, Zerilla, etc. Next up, part 8, which covers closures. Thank you for listening.